Yep. Welcome back, everyone, from lunch. You're all looking very excited to be here because I am very excited to be here because we've got Richard Billington who's coming and presenting about AWS securing your organization's accounts, which I think is something that we could all do a little bit better, I'll be honest. Richard is a bit of an AUSCERT veteran. He's worked at AUSCERT for a fair few number of years. Also established the SOC at Suncorp. So I just feel like I'm following in your footsteps the whole time. So I'd just love if everyone could come up and give a big round of applause for Richard Billington.
Thank you. Good afternoon, everyone. Thank you for that introduction. As he said, my name is Richard Billington. I'm a member of an incident responder in the AWS CIRT team. CIRT stands for Customer Incident Response Team. So can I have a show of hands? Can I have a show of hands for those who've heard of the AWS CIRT team before, the Customer Incident Response Team? Fantastic. I was expecting no one, and there's just under maybe half of you. So a quick introduction. The AWS Customer Incident Response Team is a team of people that helps customers when they have security events in their AWS accounts on the customer side of the shared responsibility model. So the customer's having a bad day, they can come to us. We're an extra set of hands with AWS knowledge and incident response knowledge that can help do some triage, analysis, recommendations, and help them work through the security event. So as part of that, we see a number of incidents and events that customers have in their accounts. And we work with everyone. So we work with small individuals, small companies, ISVs, right up to large enterprise. We're free if we're needed. So all you have to do is log a support case with AWS, and if needed, there's a lot of good people in AWS support, a lot of good security people in AWS support, but if needed, it will come through to one of us. So when we look at some of the information we have, we can sometimes be just numerically skewed towards the smaller customers, just because of how many there are of them and how many events we see. So I wanted to, in this presentation, switch focus to look at more of the enterprise side of things, the larger customers. And there's a few parts I'll point out in a slide or two about what that means in terms of what we're looking at. Most of this shouldn't be too complicated. Some reason it got put as a high, I think I must have selected that, a high technical difficulty. Some of the concepts are quite technical when you go into the implementation of them, but I'm hoping that what I'm going to talk about won't go over anyone's head. You'll be able to take it back and ultimately, as homework for everyone, check your own organization, see if you've implemented all of these in your own accounts, in your own organizations. So what are we talking about today? I'm going to give a quick overview of the problem space or the opportunity. And then we've got 4 events, and for each of those I'm going to be looking quickly at an example of what the event is. I'm going to be looking at how to respond to it. And then the most important part, how to protect or prepare, depending on what the event is, for those sorts of events. And then I've got the call to action. I've got some homework for each one of you, which, no surprise, go back to your organizations. There's 6 dot points in that homework. Check those dot points. Are we doing these things? Some of them are quite trivial. Some of them are perhaps a bit more work. Use your risk frameworks. Should we do this or not? But they're things that I think I would love everybody to go and check whether they're doing them. One aspect of, actually I'll move on to an overview, and starting with the enterprise. Why the enterprise? What differences does an enterprise make? And the first is just, as an enterprise, there are people who do security. I'm sort of assuming that to be classed as an enterprise, you've got at least someone there, maybe part-time, hopefully not, maybe a team, maybe multiple teams, whose job it is to think about making things secure or helping everyone make things secure. And that means that just as, again, almost by definition of being an enterprise, you're going to have some baselines. You're going to have patching, some vulnerability management. You've got some other guardrails. You've got policies, procedures already in place. And this means that you can have some slightly different problems, specifically scale and complexity. So as you grow, especially as you grow larger and larger, scale becomes important. What could have been a manual task for 3 people has to now be some sort of automated task for 300 or 3,000 people. And with that scale and the complexity of every group and every team wanting to do slightly different things, different org units wanting different tools and different ways of working, that complexity leads to centralization. And I'm not talking about one product, everyone shall use this, although sometimes that's the case. But it's rare to find a large enterprise where every team is using a different product for every single service they're using. Where they want to make their differentiation, where they really care, they may. But in general, you're not going to want your own HR system for your little team or your own whatever. You use the services that the organization provides. So you end up with a lot of centralization of information, of data, of access. With that also comes what I'm calling assumed guardrails. So when you start splitting an enterprise into different teams that do things, you will have potentially a team of developers who are creating the next killer Gen AI application, of course, maybe with a bit of blockchain thrown in because everything has to. But they're not going to, well, hopefully they're not going to be thinking too much about having to maintain the network or which AWS account is going to be accessing through the internet. They've got their gateway, their firewall all set up. They just plug into the existing infrastructure managed by other teams. But with that comes the assumption that those teams have all got whatever security I might need. You know, I don't have to think about it. I'm not concentrating on it too much. They've already thought about it. They've probably already done it for me. And that's not always the case. And there's a few things that I want to talk about around assumed guardrails. The other part of what I'm talking about today, this is not going to be a list of do these things to secure your AWS accounts. We've got plenty of documentation showing you how to do that. We've got the security reference architecture, which is fantastic, the well-architected review. We've got startup security baseline if you're a smaller company and want to remain agile. We've got a lot of doco telling you what you should be doing. I'm hoping as enterprise customers, many of you will be doing a good chunk of security well or well enough. So what I'm focusing on here is the things we see go wrong or cause problems with enterprise customers when they're doing the majority of security things. So this is not a list of do these to be secure. This is a list of are you doing these to help minimize your chances of needing our assistance. So trying to minimize my own workload. So today's opportunity list, and we've got 4 opportunities that I'm going through. Number 1 will be an opportunity for everyone, no matter what your size. This is true for all size customers. Number 2 and 3 and 4 are more enterprise focused, but I'm hoping that all size customers can take stuff away from 1, 2, and 3 to be able to implement. Number 4 might be slightly more on the enterprise side, but I'm hoping and imagining it will shift towards smaller companies as well. Number 1 is keys. So long-term credentials, access keys, and the use of those. Number 2 is disabling of security controls. So this is stopping things you're relying on from working. Number 3 is unwanted things around your identity providers. And number 4 is centralized credential storage, sometimes called PAM or known as privileged access management, but I'm not just talking about PAM solutions, I'm talking about anywhere where you're having a central store of identity so you can govern it and monitor it, but hence you now have a concentration risk, you have that centralization of credentials. So these are the 4 things we're going to be covering today. So we'll start with number 1, long-term credentials. And what am I talking about? I'm, of course, talking about access keys. Now, access keys are used by everybody. Every customer is impacted by having access keys. Where I see this happen in enterprise tends to be with the older accounts, the older keys, the legacy, or maybe acquisitions, where a reason might be we had a project, or we have a project, to migrate that to our latest and greatest setup account security controls. We just haven't got there yet. So again, this might not be a failing of security policy or posture. This might just be a we haven't got there yet, or an acquisition, or some sort of legacy that hasn't yet been dealt with properly or touched on. So what exactly am I talking about? Well, first of all, this is keys stored in insecure, in quotes for a reason, or multiple locations. And that's a fancy way of saying we don't know. When a customer says, well, how did this key get out? How did it get used? We don't know. We handed the key, AWS hands the key to the customer. So the first question we ask back to the customer when they ask that is, where were you storing the key? What did you do with it? Who had access to it? Where did you save it? Where did you use it? And more often than not, the answer to this question tends to be, again, thinking with those legacy apps in mind, well, it used to go to this team, and then we restructured, and now it was this team, and this person left, so now this person got access. And in fact, we shared it with this team because they wanted to get set up quickly. They've now moved on to this key, but they might... There's all sorts of places the key has been used, and so it's very difficult to pin down how it was obtained, where it came from. But there are some more concrete ones that we see. Common ones you might not be surprised to see. Keys uploaded to a code repository. I'm including this if you keep it in some documentation. So maybe you have a wiki page where you put your credentials, even though you shouldn't. Anywhere where you're storing keys where it should be for code or documentation. And then returned as part of debugging messages or logging messages. So you might have a Lambda function running. When things go well, everything works fine. But if this weird input gets sent to it, it has some sort of error, and either debugging is left on or the error messages get sent back to the customer somehow. So if you see configuration files like this, where on the right-hand side, debugging equals true, if you're running that in production, that can often lead to access keys that are in environment variables or configuration files finding their way back out. So this is what we're talking about. This is sort of some of the reason why we see access keys being a problem. How do we respond to it? And now for all the response sections, again, I'm looking at this sliver of what we see, not a holistic response. This is not something you should go and write a playbook based on. This is your playbook when it comes to a key being in the wrong place or being obtained by a threat actor. These are some of the things you should think about doing and going into more detail for. So first and foremost, try to, if you can, identify, well, how did it get accessed? How did this credential get obtained? So if it was through a Git repository, remove it from the Git repository and the history. If it was through an error message, fix up your code to not send error messages back to a customer. If it was unknown, rotate the key, set up some monitoring, hope it doesn't happen again, keep track of where you actually store the key this time. Now we know a key has been obtained, so what was the key used for? What was done? So check, for example, CloudTrail, great source of information. I live in CloudTrail almost every day. What did the key do? Step by step, it did this, it did that action. Rotating and revoking the credential, of course, should be done. Make sure it and any credentials created from it, whether they're IAM users or temporary credentials, those need to be removed as well. And then undo any changes that are done. So if they created some EC2 instances, remove them. If they accessed some data, check whether the data was exfiltrated, network logs, or network transfer information. Make sure that you know what the threat actor did. And I like to think of this as drawing a tree. Every credential performed a bunch of actions. And then you recurse on that methodology. If one of those actions was creating a new credential, what did that credential do? And you can draw yourself out a tree of compromised credential, actions taken. If those actions include allowing additional access, be that changing permissions, policies, creating new users, well, now those credentials need to be investigated as well, and you draw out that tree of everything that was done. So that's how we respond. What about protect and prepare? How do we stop this from happening? Well, first of all, audit, everyone's favorite, auditing access keys. Audit access keys, see where your legacy keys are. At least now you know and can prioritize whether you should bump up the priority of this project to move it across. The next one, and you'll notice in my prepare protect and prepare, I've got one or two that are highlighted. They're the ones I think are the most bang for your buck. These are the ones that are best practice, recommended way to do it, that will get you the most benefit. And for access keys, it's using short-term credentials. So IAM roles and IAM roles anywhere. If you've got a certificate public key infrastructure already set up, IAM roles anywhere will let you use roles on premises. So this means that a server can have access based on what it is almost, or the fact that it is a server that does job X, it has role X, therefore it just gets access. And it uses PKI in the back end, the roles anywhere. So practice rotating and searching, drawing out that tree I mentioned. The first time you do it, it will take you 10, 50 hours to draw up that nice tree. The second time you do it, it might take you 10 hours. The third time might take you 3 hours. And by that stage, you might have a tool that helps, or you might be using a different service or open source project or whatever it is to help you get an idea of what has actually happened and what that credential did. And then one specific one, when it comes to Git, developers using code, Git secrets is one option. There are many others. We have one that we run internally to AWS. Every time I run a Git commit, whatever, it checks the code, sees if there's anything that it thinks might be a secret, and just says, no, go fix this. And that can really help reduce the number of secrets that get committed to code repositories and live there in history forever. Number 2, disabling security controls. So this is where a threat actor comes in and stops some of your security controls from working, doing whatever they should be doing. Surprisingly, this is actually less common than I would have thought. I would have expected, if I put on I'm going to brainstorm what a threat actor might do, I want to get access, I want to stop people seeing what I'm doing, and then I want to do whatever thing I'm there to do and profit. We don't see as much of this as you might think. Now, maybe that's because the actions the threat actors want to take can be done fast because it's all scripted or in an API, and one of the benefits of cloud is speed for good and bad. Maybe that's why. I wish I knew. I don't. However, the reason it's in here is it can really hurt visibility. Think about your SIEMs, your on-prem logging, monitoring, detection systems. Now, if someone turns off the logs coming into it, yes, you may have an alert that says, hey, logging's been turned off. How quickly do you respond to that? Are you able to go, oh, it's turned off, get in there, turn it back on, all within a minute, 5 minutes, a day, a week? I mean, what sort of time frame is realistic, and how much can be done with scripting in that time frame? And that's time frame where your other alerts are not functioning because they don't have the logs to alert on. So that's why this one it can be quite important, especially if you're doing post-incident analysis where your logs now may not exist, full stop. I'm just going to leave that one over there. So what do we see? We see 3 main things. One is CloudTrail being turned off. So things like delete trail, stop logging, or put event selectors, or update trail. So anything that will change what is being logged, where it's being logged, how it's being logged. The next is Amazon Guard Duty, so threat detection service, getting turned off by either deleting the detector, updating, and update here is a fancy word for disable, or stopping monitoring of member accounts in your organization. The last one is network access. So for example, changing security groups, creating security groups, or attaching internet gateways. So if you're in an organization where everything goes out through some sort of proxy or transit network or setup, well, what happens if I plug the internet straight into my VPC? And if I change a security group? Well, now I'm a long way to getting the data straight out. So how do we respond to that? Well, restoring the altered controls is, of course, important. We want to close those security groups, remove the internet access, turn back on guard duty, turn back on whatever logging has been disabled. CloudTrail, anyone familiar with CloudTrail event history specifically? Not the trails themselves, but event history. So with CloudTrail, you can set up a trail, and that sends all logs to wherever it's going, an S3 bucket, CloudWatch, and then onto your scene. Event history is 90 days worth of only management events. It's on, it can't be touched, it can't be changed, it's immutable, full stop, cannot be altered, cannot be touched, cannot be deleted. It's just always there 90 days. And it's a fantastic source of what happened if things get turned off or if, for some reason, we didn't have logging turned on. But it doesn't capture everything, and it's only stored for 90 days. It's also not in a format that's overly easy to search, in my opinion. So that comes on to our next step, which is ask AWS for help. That's why my team exists. We might be able to get your event history and send it to you in a much more ingestible and searchable format. We might be able to search it ourselves, freeing up you to look at other parts of whatever you're investigating. But still, after all that, you're still going to be lacking visibility. S3 data events is a great example. When they get turned off, they're off. There is no recovery because the events do not exist unless they're being logged. So you will, if this sort of thing happens, you will have lost at least some visibility. So how do we go about either protecting or preparing for this? And thankfully, this is one we can protect. Excuse me. So highlighted here, one of my favorite things in the world, or at least my working world, service control policies. These are a fantastic set of guardrails. Like you're driving down the freeway, you have the big concrete barriers, lets you go faster. These sort of guardrail controls, SCPs, are fantastic to say, we never want logging to be disabled anywhere in our company. Apply. And now those actions will just not work in any of your member accounts. Of course, there's always exceptions. So with that, you can either carve an exception into the SCP or just the infrequent occasion you might want to be disabling logging for some reason or disabling guard duty, you could take the SCP off, do your action, and put it back on. But the act of doing that requires a different credential, a different set of access. And so guardrails, SCPs, are some of the most important ways to stop all of these unwanted invisibility, lacking of visibility, actions that get taken. Secondly, when it comes to your logs, CloudTrail event history is immutable. If your policy says we store logs for a year, or whatever time frame, make them immutable. Stick them in S3 and use S3 object lock to keep them there for a year with lifecycle management to delete them and clean up and whatever's needed. But make them so that if a threat actor gains access, they can't delete your logs. And lastly, and there's lots of ways to do this one, AWS config is a great service. It does a lot of things. I think of it as a detection service. There's a lot of built-in detections for things that you may not want set up like that. So for CloudTrail, is it enabled? Is multi-region enabled? For guard duty, are we centrally managing our guard duty? Is all that enabled? Do we have any security groups that are a little more permissive than we might like? And of course, you can write custom policies. So anything you can think about checking, you can write some custom logic to go and check that. As I said, to me, I don't mind what you use to do this checking. AWS config is a way that you can do it natively. There's other software and other products you can use to do those sorts of checks as well. A couple of examples of what I'm talking about with SCPs. CloudWatch and also, CloudTrail and also CloudWatch. We don't see as much CloudWatch, but it's a place where logs can live and can be altered. You can put an SCP in place. The QR codes link you to the website with full details. This is just a little snippet, but you can see the idea. It's a simple policy that says deny these unwanted actions. I mean, IAM policies can get tricky if you want them to or if you need them to, but you can get some very simple ones. And this, put into an SCP in your organization, means that none of your member accounts can delete alarms, delete dashboards, stop logging, update trails. Now, some of those you may want. You'll have to check which actions you do actually use or want to use in your accounts. But there's a good starting point at that website. Similar for guard duty. This should look almost identical to the previous one because the only thing that has changed is what actions are or aren't allowed. And in this case, we stop various guard duty actions that we don't want to happen. And again, the website has a pretty large list. There's some key ones like those 3 I've got up there that I would recommend if you want to minimize the policy for whatever reason. So when these do get turned off, what do we see? So for CloudTrail, here's an example of a delete trail event where someone's just made an API call. Just like turning it on, just like creating an EC2, we need to provide customers, AWS needs to provide customers the ability to turn services off when they've turned them on, but we don't want a threat actor turning them off. So it's just like any other API call, updating a detector for guard duty, deleting a detector for guard duty. These are just another API call, but one you probably want to stop happening in your enterprise. So now we move on to number 3, unwanted identity provider access. So what am I talking about here? Well, identity providers are the preferred way to access AWS. So we don't like IAM users anymore. Don't like's the wrong word. We recommend against using IAM users. We recommend federating your access for an existing identity store. And that means creating a trust between that identity provider and AWS. So AWS now trusts that identity provider to do whatever validation is needed of the credentials, the MFA, check the user is the right thing, and then make that linkage of, well, here's the user we trust and we know. AWS, let them in, let them do what they need to do based on whatever policy is defined. But the trust there is between the identity provider and AWS, not the user and AWS. Unfortunately, this is more common than I would have expected. So having an IDP where, sorry, I'll get to that in a sec, but so mental model is think of an IDP, in this example, as a credential vending machine. It gets credentials that allow you into AWS. Now, of course, they do more, there's a lot more that they do, but in terms of the access I'm talking about, they're providing the credentials, a third-party IDP. So there's 3 ways that this can be used. One is a user credential gets compromised, and that means, just like an IAM user, one user can do whatever that user can do. The second one is where things start to get a little more interesting or problematic, and that's where an admin credential is obtained. And this means that within the IDP, that user might be able to create new users, change passwords, add or remove MFA devices, all sorts of interesting things. And the third one in purple, adding a new IDP. So this requires access into AWS already, but once you've got access, there's the option of adding in another IDP, maybe controlled by the threat actor, where they can do whatever they like. So even if they only had the first one, or an IAM key, or a user, if that user can perform that action of adding an IDP, they can now add that IDP, set up whatever access and permissions and policies they want. So how do we respond to that? Well, first and foremost, there's now 2 parties involved. There's AWS, but there's an IDP provider as well. So work with your IDP provider and your own logs to know which accounts were accessed, what got changed. Just like I talked about drawing that tree of access, what did they do? If it was more access, what did they do? And drawing out that tree. Same with your IDP. What's been changed? How has it been changed? What's been used? Of course, you'll want to rotate credentials and remove those unwanted users. You might want to, depending on how long that takes, and it can take a long time if there's been a lot of users changed, you might want to break that trust between the IDP and AWS. And that means the default users will not be able to log into AWS anymore. So how do you do investigations? Well, you need to use break glass access, and I've got a slide on that in a second. You will, of course, also want to investigate the actions performed inside the AWS account as you would for any sort of event, security event in AWS. So now protecting and preparing. So number 1, set up appropriate break glass access to AWS. You need to be able to get into AWS when there's something wrong with your IDP. When there's a security event, by definition, we're talking about some controls have failed already. So you can't rely on all your controls to always work properly. We've had some fail already. In this case, it's that IDP, that access mechanism, So you need some other way to get in. Another one, do you have an SCP that prevents adding IDPs? I know that's a lot of acronyms, but how often do you add an IDP to your organization? Now, maybe you're changing providers. Is that every 3 years maximum? This is not a frequent operation that you want to be performing. And root users, make sure they're appropriately secured. One takeaway I'd like all of you to have, if you think of root users more like a get-out-of-jail-free card, that's the mental model I like to have with them. They're a shared account, so they shouldn't be assigned to a person. They're a great way to get in and not have any restrictions put on you, except SCPs, if you're a member account, of course. But think of them as a get-out-of-jail-free card. Lock them away, don't use them, and I'll get to break glass and how that should be done in a second. The last one is practice. If this happens, you want to be able to do the actions you want quickly. So how do you go about severing that trust? Have you got that relationship with your IDP in place? Can you reach out to them, call them, get help? How do you do mass credential resets? What comms do you send out? So think about these, document some of these, maybe simulate, test, log, run these searches. Give it a go. The first time you do any of this, it will take you so much longer than you will think. So on to that break glass access. And this is a page we have that details how it works, but there's two parts to it at a high level. One, create 2 IAM users in your organizational management account, the top account in your structure. Each of them should have 2 MFA devices or more for redundancy, and you should be alerting if these are used. These should not be used day to day, so you want to alert to understand any time these are used. The second part is to get into each of the member accounts. And for that, you create a role in those member accounts, but that role needs to be special. It needs to be only able to be assumed by those 2 break glass users, and it can't be changed by anyone except whoever you want. So a cloud admin or those IAM break glass users or whatever's appropriate for your situation. So what you're trying to do is you're trying to carve out a slice into each of those accounts that can't be assumed from anywhere except that those 2 IAM users where you have your MFA keys locked in a safe, a physical safe, so that nothing hopefully can go wrong with those. So number 4. Number 4 is centralized credential storage. And for this, I'm talking about not just PAM solutions, but anywhere where you store credentials centrally. Now, I don't want in any way to try and convey the message that PAM solutions are bad. They're not. They solve a wonderful problem. Any central credential storage allows you to put thought and time into controlling those credentials. What I want to leave you here with thinking, what I want you to leave here thinking about is what are you storing in them, as well as how you're securing it a bit. But for this, we're in a position where this access to this credential store has already been obtained by a threat actor. So that's the place we're coming from. That could be a compromised user account that had access to some number of credentials in there, but we've already come from a point where they've got access to this. So when we get to that protect part, there's nothing we can do to protect because we're assuming a bunch of controls have already failed. So a lot of this will be on just prepare for this. So an example here. Well, a threat actor, as I mentioned, gains access to a user, maybe more, accesses the credentials that are stored in that PAM system, that credential management system, and then gets additional access based on those credentials. So the fundamental idea here, though, is that credentials that are hosted in a credential store are only as secure as the credentials you use to access it. Now, that may make you go, oh, yeah, of course, why wouldn't you think that? That disconnect can become apparent where you're going, where if you have a mental model of this credential store is a secure place to store credentials, without that linkage of that are only as secure as the credentials used to access them. Now, what you do and don't store in there, it will be up to you, your risk policy, but I do have one recommendation of please don't store these in your central storage. Consider these more privileged than your central storage, and I'll get to that in a second. So key takeaway, what are you storing in these credential stores? And what credentials allow access to these other credentials. So when we're responding to this, first step, identify what credentials have been accessed if you've got appropriate logging. Hopefully you do. Keep good methodical notes of what actions you take. In this situation, we're going to be resetting or changing a lot of credentials. You need to know exactly what was done by who, where, and where the new credential was stored. So we're going to regain control of our highest level credentials first. And by that I mean, if credential A can change credential B, it's a higher level credential. You do get circular dependencies. This is a rough guide, but generally don't start with the individual users. Start with the management, the administrative users, or the ones that protect more sensitive data, of course. When you do rotate them, you may not be trusting your credential store. And in this scenario, and possibly only this scenario, this is where you want some sort of out-of-band, shadow IT style of secure enough place to store it in the interim. Because the other option is putting them back in somewhere you might not be 100% sure is secure yet. There's a gap here. At an appropriate time later, you want to review your credential storage, specifically what is being stored in there, how your policies govern what is stored there. And once you've contained everything, we want to transfer those credentials, and this is a key step, back from whatever temporary actions we'd taken, and this is why we're keeping methodical notes, back into the new, assessed, hopefully slightly improved credential store, and get them back to a policy meeting location. And they should be changed in this move. Otherwise, you now have credentials that have been stored in two places, and you may not know how they did or didn't get out if something went wrong. So for preparing for these, document and simulate. How would you go about doing this? And most importantly, what do you store in there? Do you store, the one in orange, your organizational management account root user? This is an account that cannot be limited by SCPs and can do almost anything in your entire organization. For this one, separate hardware tokens, stick them in physical safes, make someone drive that hour, 2 hours to a physical location to unlock a safe. It's much better than having this obtained by a threat actor ever. You should never have to use this account, almost never have to use this account. And lastly, threat modeling. Have a think, sit down, set some time aside to think what could happen if these credentials in the credential store get accessed. So on to homework. So these are the 6 things I want everyone to take away and go and do. 1, limit your long-term credential usage, so your access keys. This can be a policy control or a technical control or both. Have SCPs in place that prevent stopping guard duty, disabling logging, or adding an IDP. Set up break glass AWS access. Don't keep extremely privileged credentials in a network accessible location. So that's the first 4. And the last 2, have processes in place to rotate credentials and disconnect your IDP if you need to. Hopefully you'll never need to, but if you do, doing it fast will be important. And lastly, monitor for changes to SCPs, root users, and break glass access. These are things that should not be changing or used frequently, so you should want to know when they're actually used or changed. And with that, thank you for listening. I'm happy to answer questions afterwards. I think we're out of time at the moment, but we've got a bit of time? Cool. Also, we love our data at AWS. There's a feedback survey QR code. Feel free to snap it, give feedback. We love our data. But if we do have question time, then if there's any questions, feel free to hit me.
Big round of applause for Richard. Got one question here. Do you still see management account root credentials or root credentials in general being compromised?
Yes.
There you go, fear of God. Put up those alerts.
Hopefully less and less over time, but yeah, yes.
I have a quick question myself. Mm-hmm. As someone who is currently in charge of auditing a AWS account that is pretty much just a big wrapper for an EKS cluster. Do you have any advice for basically reviewing a bunch of IAM roles as opposed to the users?
I suppose I fall back onto the idea of guardrails and freeing up developers to do what they need to do. So having a central check every policy for every time doesn't scale well. So at some point it comes down to trusting your developers, giving them guardrails to work between, putting security champions within the teams so that they're thinking about security as they're building policies. So I suppose one mental model AWS has given me that I love is developer team and security team are often thought of as somewhat adversarial. They say no, they want to develop and fast features. It's a big culture shift, but if you can shift that to security and dev want to create a secure product, they now have a shared goal of that secure product. So if you have an insecure but fast and good product, that's a fail for both teams. If you have a product that doesn't get shipped because security keeps saying no, that's a fail for both teams. There will still be tension and disagreement, but the goal of the security team is not how do we enforce security, it's how do we get a secure product. And that's a subtle mind shift that helps to make sure everyone's working towards that secure good thing.
Just got someone to request to see the last 2 slides again.
These two, I assume?
I think that's what, yeah, all the phones came out. Just while people are taking photos, just quickly, Chris Horsley is asking
Hi, Chris.
to root accounts again, what are the top ways they get compromised?
For root accounts? I don't know, is the short answer. It probably falls into that top category of mismanaged credentials. So I have yet to have anyone give me a good reason to have an access key for root. Full stop. There's some things you need root to do. There's 10 of them, I believe, unless we've changed it. There's 10 things that root and only root can do. None of them are the sort of things where you need a long-term credential. So access keys for root, massive red flag for me. And therefore root should be a username, password, and the pluggy thing, MFA. And MFA, ideally hardware MFA, 2 of them stored in safes. Now, the management of large organizations, member root accounts, that's a different topic for discussion because there is a lot of manual process involved in that and there's different ways to do it. But especially for that member org account, no matter how big your org is, you might get, 1, 3, 5 AWS organizations. I have yet to come across an organization that has too many. This is now still a small enough number that you can do it manually. It can be a manual process for anything you do.
Awesome, thank you so much. It's been really insightful. Can I get one more massive round of applause for Richard Billington?
Yes, thank you.